Alright, we're going to combine our previous two lessons of negative exponents and fractional exponents, and we're going to evaluate some numerical bases with both negative and fractional exponents. So the key to doing this is just remember that fractional exponent is read power over root. A negative exponent, for all intents and purposes, we're going to just say that the numerator is the negative part. Although the denominator can also be negative, it's difficult to work with a negative denominator, so just for all intents and purposes, anytime you see a negative exponent, assume it's only the numerator. So therefore, you're taking a positive root of something. So for example here, we have 4 to the negative 5/2 power. Let's evaluate the root first. Again, power is 5, and root is 2. Well, we know what the square root of 4 is 2, leaving us with a negative 5th power. Now we have to apply some negative exponents here. 2 to the negative 5th means 1 over 2 to the 5th. As soon as that negative exponent crosses the fraction line, it becomes the opposite sign. And 1 over 2 to the 5th is 1 over 32. Okay, here's another example. We have 81 to the negative 3/2 power. We're going to evaluate this using power over root. So the power, negative 3. Root, 2. And we know what the square root of 81 is. It's 9. That leaves us with 9 to the negative 3rd power. And we'll just have to remember, a negative exponent simply means I belong in the other side of the fraction. So we're going to express that as 1 over 9 to the 3rd power, which means all I have to do is raise 9 to the 3rd power, leave it in the denominator, leaving us 1 over 729. Next example. So this isn't a fractional exponent, it's just a negative exponent. So there's no root being taken because the denominator of this fraction is 1. But the negative exponent does say, take the reciprocal of my base. So the exponent is negative 2. The base of the exponent is 1/2. The reciprocal of 1/2 is 2. We took the reciprocal of the base, therefore make the exponent the opposite sign. And 2 squared is 4. Next example, we have 4 to the 0 power times 2/3 to the negative 2nd power. Well, 4 to the 0 is 1. Anything to the 0 power is 1. And the negative exponent says take the reciprocal. So let's do that. Take the reciprocal and then make the exponent the opposite sign. 1 times anything is itself. So I'm just going to leave that one alone. 3 squared is 9. And 2 squared is 4. Okay, over here we have 4 over 9 to the negative 3/2 power. So the first thing I'm going to do, I'm just going to flip the base. That's what that negative exponent is telling me to do. The negative exponent says flip me. So I'll flip you. I'll flip you. So now we still have a 3/2 power. But because I took the reciprocal of the base, I made the exponent the opposite sign. And now we can evaluate power over root for both of these terms in the fraction. So we're raising both 9 and 4 to the 3/2 power. So let's take the square root of both 9 and 4 separately. The square root of 9 is 3, and the square root of 4 is 2. Don't forget, they're still being raised to the 3rd power. 3 to the 3rd power is 27, and 2 to the 3rd power is 8. And there we go. So now, just to go over all these really quick, to verify your solution in your graphing calculator, we had 4 to negative 5/2 power. Now, this is a tool for verification, not a tool for completion. To use your graphing calculator to verify, not to complete, you can say 4, up arrow, open parentheses, negative 5 divided by 2. Make sure you're using parentheses for your exponent here. I'll show you why. Now, if I hadn't used Let's see if I can get this a little more clear here. Can't really see that. 4, up arrow. I'm not going to open parentheses now. -5 divided by 2. Yeah, it's a little tough to see that. So now what that calculator is saying right there is that we're taking 4, tough to see it, I'll just show you on paper. If I hadn't opened up parentheses here, the calculator would say 4 to the -5 what the heck? Divided by 2. If you're not using the parentheses, the calculator is going to raise 4 to the -5th power and then divide by 2, rather than saying to the computer, I want 4 raised to a power, but the power I want you to raise it to is all of that. So make sure you're using parentheses. This is wrong. This is right. The second example, we had 81 to the -3 power. If we want to use our graphing calculator to verify, not to complete, 81, up arrow, -3 divided by 2 power. The fraction example, right here. Let's see how we would input that into our graphing calculator. 4 divided by 9. Being raised to the negative, I think it was 3/2. It was. If we want to raise this to, if we want to evaluate this in our calculator to verify, not to complete, we would have to use parentheses for both. 4 divided by 9 to the open parentheses, -3 divided by 2. Notice how they're both in parentheses here. So that's the important part about evaluating your graphing calculator.